Hello everyone, welcome to the part 2 video of Form 4 Additional Mathematics, Chapter 4, Indices, Surds and Logarithms. So this is a part 2 video of logarithms, and in the previous video we learned some basics of a logarithm, and now we are going to continue with a few more basics of a logarithm, and the first one here is antilog. So in our previous video, we learned how to find the values of a given log base 10 of 1000, for example. We can use a calculator to find the values here, which is equals to 3. The 3 here, we call this the logarithmic values. So what if now you are given logarithmic value and we want to find this number? When this happens, we say we are finding the antilog of the number 5. Okay, so if log base 10 of n equals to x, then the antilog of x equals to n. We look at some examples here. So example number 1, determine the values of the following. Okay, find the antilog of 5. So we can use a calculator to help us to find the values. Hence we have my calculator here. Remember, when we want to find log, we use this key here. But if we want to find antilog, the first thing we have to do is you have to press the shift and then you press the log key here. So the screen here will show this. So in our question, we want to find antilog of 5. So now we press 5. You have this, which is the meaning of antilog of 5. And then you press the equal key, you get 100,000. That's your answer. So 100,000, that's it. The antilog of 5 is 100,000. So now you take a calculator and you try to find the values of antilog 2.1423. And the answer is 138.7714. We try one more. Antilog of the negative 2.5676. So when you are looking for antilog, the values here can be negative. So you use the calculator to find the values now and you get negative 0.002706. So that's all for antilog. We move on to inverse function. So now we are looking at an inverse function involving logarithm. Okay, so now you're given a function f which maps x to 2 to the power of x. In chapter 1, we already learned how to find the inverse function of a given function here. So we now try to find the inverse function. So we rewrite this in equation form. And the next step is we let y equals to this. Now this is the step for finding the inverse function. We let y equals to 2 to the power of x, which is this. Then we move the 2 here, and you will get log base 2 of y equals to x. And this we learned in the previous videos as well. How to convert from an index, how to convert an equation in the index form to an equation in the logarithmic form. And now from this equation here, since the inverse of 2 to the power of x equals to x here, so here we rewrite this here, and this x, and since 2 to the power of x is equals to y, so we can rewrite this as y, and the x here, which is this x, is equals to log base 2 of y. So we try to change all the x to y in the next step. Okay, so 2 to the power of x is equals to y, which we get from here, and x is equals to log base 2 of y, which is from here. So now we get rid of x, we only have the y. So we rewrite this again using x as a variable. So you have the f inverse of x equals to log base 2 of x. So this is actually the inverse function for the given f function. If you're given a function of fx equals to 2 to the power of x, the inverse of f will be log base 2 of x. So the conclusion from here is, if you are given f, the function f which maps x to a to the power of x, then the f inverse will be log base a of x, which is this, log base a of x. Okay, so for example, if you are given a function which is 5 to the power of x, then the f inverse will be log base 5 of x. Log base 5 of x. Try again. The inverse of f which maps x to 12 to the power of x, the f inverse will be log base 12 of x. Now if you try to show this relation between this function and inverse function in a graph form, okay, we take one example here. Okay, given function of f of x equals to a to the power of x, we draw the graph. Generally the graph will be a curve as shown. And then remember, when we learn the properties of inverse function, we can draw the inverse function of this graph if we can find the reflection of this graph onto the line y equals to x. Okay, so this is fx. So the f inverse will be the reflection of this line onto this line, which is y equals to x. So when you reflect this, it will be reflected to this side, okay, this side here. And then since we already learned that if fx equals to a to the power of x, then the f inverse will be log base ax. Hence this line here is y equals to log base a of x, which is the reflection of this y equals to a to the power of x. So this is just another property that you need to understand before we can move on to the next part, laws of logarithm. So in the laws of logarithm, we have the three basic law here. Okay, so before we learn how to use the law, we try to prove the law. The first one is the product law. We first let x equals to a to the power of p and y equals to a to the power of q. And then when we move the a to this side here, okay, when we move the a to this side, you get log base a of x equals to p. Same goes to this. When you move a to this side, you get log base a of y equals to q, as shown here. Okay, so you move a here, you get log base a of x equals to p, log base a of y equals to q. So the product law here involves the multiplication of index number. So if we have x times y, since x is a to the power of p and y is a to the power of q, so we have this, the multiplication of the index number. And then since the base here is the same, a and a here is the same, we can use the law that we learned in the indices to simplify this, and you get a is equal to a to the power of p plus q. And then when we move a to this side here, you get log base a of xy, and then which is equals to p plus q. And now remember this p here is log base a of x, and q here is log base a of y. So we can rewrite p and q here by using this log base a values here, which is p is log base a of x, q is log base a of y. So now you get the product law, which states that log base a of x multiplied with y is equals to log base a of x plus log base a of y. A few examples on how to use this product law. Okay, so here we have log base 5 of 2 times 3. So you compare this to this, yeah, it's a multiplication of value, so you can use the product law. You can separate 2 and 3 here by using this part, log base a of x plus log base a of y. So this becomes log base 5 of 2 plus log base 5 of 3. So you have this. Try again. This time you have log base a of 4 plus log base a of 5, which is this part here. Okay, so when you have this, you can simplify this, becomes this, which becomes this. So notice that the base must be the same. Okay, so base a and base a is the same, then you can use the product law. If the base is different, one is a, one is b, you cannot use product law. Okay, so now when you combine this, you get 4, which is x here, times y, which is 5. So you have log base a of 20 because 4 times 5 is 20. So you can use this law to help you to simplify given logarithmic values. Now we go to the second law. We have the division law. So in the division law, again we use this to help us to prove the law. Since the division, so we have x divided by y. X is given as a to the power of p and y is given as a to the power of q. So when you divide here using the law of indices, p minus q, a to the power of p minus q. And when we move a to this side, we move here, it becomes the log base a of x over y, and then the p minus q here, the index becomes the value p minus q. And then we substitute p here with log base a of x, and q here we substitute with this log base a of y, we get this. So whenever you have the log of x divided by y, you can rewrite this as log base a of x minus log base a of y. We look at examples. So given log base 5 2 over 3, we can rewrite this in this form as log base 5 of 2 minus log base 5 of 3. Or if you are given this, you want to simplify this, you can rewrite this, combine these two, become one single log, which is log base a of 8 divided by 4x over y. 8 over 4, which is log base a of 2. We have a power law here. Again, we use this to help us to prove the power law. We have x to the power of n. So since x is here, we replace x with a to the power of p with the n here. So using the law of indices, p multiplied by n, you get this. And when you move a to this side, the left hand side, you get log base a of x to the power of n, and then you have p times n. So remember p here, p is this p here. I rewrite this as np, right? It's still the same thing. I just rewrite pn to np, and the p I replace with log base a of x. I get this. So this is the third law, power law. So you can see that when you have the x to the power of n, the n here we can bring to the front of the log, becomes this. N multiplies log base a of x. Okay, we look at a few more examples, maybe it's clearer for you. So now we have this log base 5 of x to the power of 4, which is the same as this formula, this law here. We can bring n to the front of the log. So it means we can bring a 4 to the front here. So now you get 4 times log base 5 of x. Now, if you have a log base 5 of xy, so notice that it's in the brackets, it's to the power of 3, then you can use this power law and you move the 3 to the front here, so you get 3 log 5 of 3 log base 5 of xy. There's one common mistake here. If you are given this, you cannot move the 3 to the front as what we've done here. Okay, so this is not equals to 3 log base 5 of xy, because the power of a 3 only applies to y, where x is still power 1. But for this case, the power of 3 applies to both x and y, that's why we can move 3 to the front. And of course, if you are given 2 log base y of 3, which is this form here, we can change to this form. So you can bring the 2 becomes the power of 3. So you can write this as log base y of 3 to the power of 2. There is another common mistake here is, if you are given log base 5 of xy and the brackets is here to the power of 3, means the power of 3 applies to the value of the log here. So when this happens, you cannot use this formula because the power of n here only applies to x. But for this case, the power of 3 applies to the whole value, the whole logarithmic value. So this is not equals to 3 log base 5 of xy. So you have to be very careful when using this law. So now we already look at how to prove all these 3 laws and how to use them. We try to combine all these 3 laws to use them in the following examples. Example number 1, express the followings in the terms of log base 5 of 2, log base 5 of 3, and log base 5 of 7. So you are given this, you want to express this in these terms. Okay? So since the multiplication here is involved and the division here involved, we need to use the product law and the division law. So first we can use this division law here to separate the upper part and the lower part, the denominator part and the numerator part. Okay, so we have this equals to log base 5 of 2 times 3, and when division here, you use this, which is minus minus log base 5 of 7. And now we still have to settle this part, which of course we are using this product law, which is equals to log base 5 of 2 plus log base 5 of 3 minus log base 5 of 7. That's it. Question B. We have log base 5 of this. Okay, so first we use the product law. So we have log base 5 of 2 to the power of 5 plus log base 5 of 3 to the power of 4. Then we use the power law here since the power is involved. We have a power 5 and a power 4 here. Okay, so according to this law, we just bring the m to the front here. So we just bring the 5 to the front here. So you have 5 log base 5 of 2 plus, and the 4 we just bring to the front here. We get 4 log base 5 of 3. So now you show this in terms of log base 5 of 2 and log base 5 of 3 only. That's the answer. So now we have question C. We have log base 5 of the square root of 21. Okay, so the square root here, we need to change this to the power. So remember, the square root is power of 1 over 2. 1 over 2. And from this power law here, we can place the n in front. So we place 1 over 2 here in front. We have 1 over 2 log base 5 of 21. And now we will need to do something with the 21 here, so that we have a combination of 2, 3, and 7. So 21 is actually 3 times 7. You have log 3 times 7. Right? So using this product law here, we can rewrite this as 1 over 2 log base 5 of 3 plus log base 5 of 7. So because the 1 over 2 here multiplies the whole log thing, so we have to put a bracket to show that the 1 over 2 actually multiplies log base 5 of 3 plus, and the 1 over 2 log base 5 of 7. Now question number 2. Given that log base a of 2 equals to 0.551 and log base a of 3 equals to 0.749, determine the values of this log base a of 6. So we have the 3 formulas here, the 3 laws here given. So we have log base a of 2 times 3, and we can use a product law here to help us to rewrite this as log base a of 2 plus log base a of 3. And since log base a of 2 here is given as 0.551, so 0.551, log base a of 3 is 0.749, we have the final answer as 1.3. We try question B. So I rewrite this here, log base a of 9. So since we only have a 2 and a 3 here, we need to use a combination of 2 and 3 to get 9. So actually it's quite obvious that 9 is 3 to the power of 2. And since we can use the power law here, we can bring the 2 to the front. So you get 2 log base a of 3. And log base a of 3 is equals to 0.749, which is equals to 1.498. So you have to be careful here to move the 2 to the front here before you multiply. Question C, we have log base a of 4 and log base a of 12. So again, we can get the value of 4 by using the 2 here. How? Which is log base a of 2 to the power of 2. And 12 is actually 4 times 3. And 4 here is actually 2 to the power of 2 again. Okay, so we can rewrite this again by using 2 to the power of 2 times 3, which is 4 times 3, which is 12. Then we rewrite this, we move the power of 2 to the front. And then for this case, we use the product law. We have log a base a of 2 to the power of 2 plus log base a of 3. And then this one I rewrite this again. And the 2 here, I move to the front here again, I get this. Plus log base a of 3. So now I can substitute all this log here with this value 0.551 and 0.749, and I can find the final answer. (2.953). Now we go to question number 3. Evaluate the followings without using a calculator. So now you are not allowed to use a calculator to find the values. Okay, so now for this, the base is very important. So we can usually convert this number so that it has something to do with the value of 2. Okay, so for example, log base 2 of 4 is actually 2 to the power of 2. And using the power law here, we can bring the 2 to the front. So you get 2 log base 2 of 2. Then remember one of the properties we learned in the first video is log base a of a equals to 1. So log base 2 of 2 will equals to 1 as well. So this is actually equals to 1. So it's 2 multiplied by 1. You get 2. We try again. Log base 2. So 8 is actually 2 to the power of 3. And 16 is 2 to the power of 4. So I move the 3 to the front first. Always move the power to the front first before you convert this. Okay, so the 4 as well, I bring to the front, I get this. So again, we use log base a of a equals to 1. So this becomes 1. And this also becomes 1. So 3 plus 4 equals to 7. Okay, for this, log base 4 of square root of 2 plus log base 4 of square root of 8. So since they have the same base here, okay, since they have the same base, we can use the product law. Okay? So the same base, when you add them, you can combine them. So we try to combine them, simplify them. So we have base 4, this is square root 2 times square root of 8, because x multiplies y here. Okay, so when you have 2 times 8, you have 2 times 8, which is 16. So the 16 equals to 4, and log base 4 of 4 equals to 1. Okay, next, since we have all the same base here, so we try to simplify them by using this formula. So the first one, since it's a plus here, there's a plus here, we can use the product law. So we have log base 5 of 4. Okay, but you see here, before you can multiply this, you need to settle this value of 2 here first. Okay, because according to this law, there must not be a value in front. So you have to move the 2 here. Becomes the power using the power law. So you have plus log base 5 of 3 to the power of 2 minus, okay, the 2 here, I move it to the front as well. So I get log base 5 of 6 to the power of. So now they have the same base, then no values in front here, we can combine. So the 4 and the 3 to the power of 2 here becomes log base 5. Using the product law, I have 4 times 3 to the power of 2. Since this is a minus here, we have a minus, we can use the division law. So we simplify this by using the division law. You have 4 times 3 to the power of 2 over 6 to the power of 2. You have this. In the previous video, we learned that log of any base 1 always equals to 0. So log base 5 of 1 equals to 0. So now we have this again. Since all of them have the same base, we can use the law here to help us. But we need to move the 2 to the front, and we need to move the 1 over 2 in the front. Becomes a power. So you have log base 4 of 2 to the power of 2 minus log base 4 of 9 to the power of 1 over 2 plus log base 4 of 12. So for this part, you can use the division law. So since they have the same base, and you have a minus here, so you have log base 4, 2 to the power of 2 is actually 4, 9 to the power of 1 over 2 is actually the square root of 9, which is 3. And we have the plus log base 4 of 12. Since it's a plus and then they have the same base, we use the product law. You have log 4 over 3 times 12. So you have 4 over 3 times 12 is 16. 16 is actually equals to 4 to the power of 2. Why we want to change 16 to 4 to the power of 2? Because of the base 4. We will try to change 16 so that it becomes another value which contains the 4 here. Why? Because you see now when we move the 2 to the front, you have 2 log base 4 of 4, and log base 4 of 4 is equals to 1, which is this, and you have this as your final value. So actually the questions involving the law of logarithms is not done yet. So we still have to learn how to simplify a given expression involving logarithms, but we will learn about that in the part 3 video. Thank you everyone.